Now add these two matrices. It is cos square theta adding with sin square theta, cos square theta plus sin square theta. Next, cos theta sin theta minus cos theta sin theta. Next, third element minus cos theta sin theta adding with cos theta sin theta minus cos theta sin theta plus cos theta sin theta. And last A22 element, it is cos square theta plus sin square theta. Now here you observe that both are equal but opposite sign, they get cancelled. Minus cos theta sin theta plus sin theta cos theta cancel. Similarly cos theta sin theta and cos theta sin theta get cancelled. Now you know that cos square theta plus sin square theta is 1. So it is 1, it is 0. It is also cos square theta plus sin square theta is 1. So because we know that cos square theta plus sin square theta equal to 1. It is trigonometric identity. Now you get 1, 0, 0. So you observe that it is nothing but identity matrix, that is it is equal to I. I is nothing but identity matrix of order 2 it is. So our answer is equal to I for this one. Now after this we have completed addition of the matrices and properties and some of the examples on that, along with the completed scalar multiplication and properties and examples. Now we go for another important discussion, that is multiplication of matrices. Here we consider the two matrices A and B. A is first matrix and B is a second matrix. For multiplying the matrices A and B, there we should remember the condition for multiplication. The condition of multiplication of matrices is that the column numbers of first matrix should be equal to rows number of second matrix. That is number of columns of A should be equal to rows of matrix B. Column numbers of matrix A should be equal to row number of matrix B. Then AB is exist, otherwise AB will not exist. And if you observe the order of the matrices, suppose A is a matrix of order M by P and B is a matrix of order P by N. Now here we observe that here the number of columns equal to P and here the number of rows equal to P, which is required condition for multiplication of the matrices. Now if you consider the product AB, AB is also another matrix. It is having the rows of first matrix and columns of the second matrix, that is M by N. If A is a matrix of order M by P, B is a matrix of order P by N, automatically AB is always a matrix of order M by N. This is regarding the order of the two matrices in case of multiplication of the two matrices. If number of columns of A is not equal to number of rows of B, we cannot possible to multiply A and B matrices. These are two important conditions for multiplication of the matrices. Now we go for example. If you take A equal to A, B, C, D and matrix B equal to P, Q, R, S. If these are two matrices, and here first we check the number of columns of A, whether it is equal to number of rows of B or not. Here we observe that the number of columns of A are 2 and the number of rows of Here columns are 2. Now here A matrix having 2 columns and B matrix having 2 rows. Then our condition for multiplication of matrices is satisfied. Then we go for the multiplication. In case of multiplication, first we start with row and multiply with the column. For that you make a row mark like this. So this shows the row is multiplied with the column. First we multiply first row. First row elements are AB. AB is multiplied with PR. Now it is multiplied like this. First we write A into P first. After that the element B is multiplied with R. Here in between I write the plus sign, that is B into R. Means here first row is multiplied with the first column. Similarly for second element, this first row is multiplied with the second column. How can you multiply? First A is multiplied with Q, that is A into Q plus this B is multiplied with the S, B into S. This means first row is multiplied with the second column. Similarly for third element, you take the second row and multiply with the first column, that is CD multiplied with P into R, that is C into P plus D into R. It is third element. Next for fourth element we go for second row, second column. Second row elements are CD, second column elements are QS. Then we multiply C with Q, C into Q plus D into S, D into S. Now this is rule of multiplication of the two matrices according to given order. Once again you check. First row multiplied with the first column. In between you take the positive sign. Similarly first row multiplied with the second column, you get the second element. And second row multiplied with the first column, you get the third element. And second row multiplied with the second column, you get the fourth element. Now this means it is A into P is AP plus B into R is BR. It is A into Q is AQ plus BS. Similarly here C into P is CP plus DR. Here C into Q is CQ plus DS. So this is called multiplication of the two matrices A and B. For next all the examples we can apply this rule for multiplication of the two matrices. Every time this row mark is remembered, this so that every row is multiplied with the column if it satisfies the condition of multiplication of the matrices. Now we go for another example. Second one, if A equal to 1, 3, 2, 5, B equal to 3, 2, 1, 6. These are two matrices. First we check the order. Here we see that number of columns of first matrix, it is 2, and here number of rows of second matrix is also 2. Both are equal. Therefore AB will exist here. Then we start according to above method. So here AB is given by, first you write 1, 3, 2, 5 into 3, 2, 1, 6. Now you start row with column. First row, first column I start first. What is first row element? 1 and 3. First column element are 3 and 1. Now it is written like this. First you multiply 1 with 3. 1 into 3 plus 3 is multiplied with 1. 3 into 1. So it is first row, first column element. Next we go for first row with second column. Second column elements are 2 and 6. For that first you multiply 1 with 2. 1 into 2 plus this 3 is multiplied with 6. 3 into 6. Now first row, second column is completed. It is second element. Next we go for second row with first column. Second row elements are 2, 5 and first column elements are 3, 1. Therefore we multiply 2 with 3 first. 2 into 3 plus 5 into 1. Similarly, for last element we go for second row with second column, that is 2 into 2 plus this 5 is multiplied with 6, 5 into 6. It is exactly similar to above one. First row, first column, first element, first row, second column, second element, first second row, first column, third element, second row, second column, it is fourth element. Now you simplify this. 1 into 3 is 3, 3 into 1 is 3. So it is 3 plus 3. Next, second element, 1 into 2 is 2, 3 into 6 is 18. It is 2 plus 18. Next, 2 into 3 is 6 plus 5. Next, 2 into 2 is 4, 5 into 6 is 30. It is 4 plus 30. So our answer is 3 plus 3 is 6, 2 plus 18 is 20, and 6 plus 5 is 11, 4 plus 30, 34. So this is the matrix. Now here it is of order 2 by 2, it is also of order 2 by 2. You got AB is also matrix of order 2 by 2. So this is the product of two matrices A and B. By using this rule, you can multiply the given two matrices. Read on this. A equal to 3 2 minus 1 4, B equal to 7 1 3 8. Now find AB. Now AB is calculated similar method. It is 3 2 minus 1 4 into 7 1 3 8. It is written like this first. Now we write the arrow mark, that is row is multiplied with column. Meaning of this, first we round up this first row with first column. For your convenience, you round up like this. Now meaning of this is the first row is multiplied with the first column. Now what you write? It is 3 into 7 plus this 2 is multiplied with 3, 2 into 3. It is first element. Similarly, this first row multiplied with the second column, you round up like this. 3 into 1 plus 2 is multiplied with 8, 2 into 8. It is second element. Similarly, first second column row multiplied with the first column, that is second row with first column, that is minus 1 and 7 is there. Minus 1 into 7 plus 4 into 3. So it is second row, first column. Similarly, go for last element, second row with second column. Here minus 1 4 with 1 8, that is minus 1 into 1, minus 1 into 1 plus 4 into 8, 4 into 8. So you get 3 into 7 is 21, it is 6. Here 3 into 1 is 3 plus 16, minus 1 into 7 is minus 7 plus 12, minus 1 into 1 is minus 1 plus 4 into 8 is 32. Now you get 21 plus 6 is 27, 3 plus 16, 19, minus 7 plus 12 is 5, 32 minus 1 is 31. It is the matrix AB. Like this you calculate the product of these two matrices A and B. Read out this one. Next go for A equal to 2 1 3 2, B equal to 1 minus 1 4 3. Find AB. Find the value of AB. It is also similar method. AB is given by, it is 2132 into 1 minus 1 4 3. Next go for row with column. Here first row elements are 2 1 and first column elements are 1 4. 2 1 multiplied with 1 4 first, that is 2 into 1 plus 1 into 4, it is first element. Next 2 into minus 1 plus 1 into 3, second element. Next 3 into 1, 3 into 1 plus 2 into 4, it is second row, first column. Similarly, second row, second column, 3 into minus 1 plus 2 into 3. So you get 2 1s are 2 plus 4. 2 into minus 1 is minus 2 plus 3. 3 into 1 is 3 plus 8. 3 into minus 1 is minus 3 plus 6. Then you get 2 plus 4 is 6. It is 1. Minus 2 plus 3. 3 plus 8 is 11. Minus 3 plus 6 is 3. It is the matrix AB. Like this you find A into B matrix by using the rule of multiplication. Similarly, we go for another example. A equal to 2 1 3 2 1 5. B equal to 6 1 1 1 0 2. Find AB. Find AB. Now, before going to multiply A and B, we check the orders according to multiplication of matrices. Now, how many columns it is having? A matrix. A matrix is having 2 columns. And how many rows of B matrix? The rows of B matrix are 2. Here columns are 2. Here rows are 2. Therefore, AB will exist. We can calculate the matrix AB. How can you find AB here? AB is written as 2 1 3 2 1 5 into 6 1 1 1 0 2. Now order of this is what? Here 3 rows and 2 columns. Its order is, it is 3 rows and 2 columns. 3 by 2. Its order is 2 by 3. So it is M by P, it is P by N matrix. So according to condition, your required matrix must be of order M by N. M by N is 3 by 3 order. You get here 3 by 3 order matrix. How can you simplify? So first row with first column, that is 2 into 6, it is 12 plus 1 into 1 is 1. It is first element. Next, first row with second column, that is 2 into 1 is 2 plus 1 into 0 is 0. Next, 2 into 1 is 2 plus 1 into 2 is 2. So it is first row with first column, first row with second column, first row with third column. Totally 3 elements you got. Similarly for second row you get 3 elements along with first column, second column and third column. Second row with first column. Next, second row is 3 2 with 6 1. 3 into 6 is 18 plus 2 into 1 is 2. Next, 3 into 1 is 3 plus 2 into 0 is 0. Next, second row, third column, 3 into 1 is 3 plus 2 into 2 is 4. It is second row with first column, second column, third column completed, you get 3 elements. Similarly, you go for third row with all the columns, 1 5 with 6 1, 1 into 5, 6 is 6, 5 into 1 is 5. Next, 1 into 1 is 1 plus 5 into 0 is 0. 1 into 1 is 1 plus 5 into 2 is 10. Now, third row is multiplied with all the columns, first column, second column and third column. Now simplify this, you get 12 plus 1 is 13, 2 plus 0 2, 2 plus 2 is 4, 18 plus 2 is 20, 3 plus 0 is 3, 3 plus 4 is 7, 6 plus 5 is 11, 1 plus 0 is 1, 10 plus 1 is 11. Now you see that it is order 3 by 3. We required order is also 3 by 3 here. Because it is m by p, it is p by n, required order is m by n. So it is the matrix of order m by n, that is 3 by 3. So this is the matrix AB. Like that you calculate required matrix. Write down the solution.